Good morning, everybody, and I thank Christian for the invitation to participate in this conference, which touches on a now urgent issue even in Egyptology. We have repeated said these days how destructive excavation is and how important it is to be present at the time of destruction. But we have not yet considered another equally topical moment, the conservation restoration process. It is equally destructive and transformative. It is also a fundamental moment of knowledge in which the conservator, the curator, and the scientists are working in constant dialogue. We can call it a three-way dance step. This dialogue between different professionals becomes a dialogue with the object itself, which is both the object of research and also becomes the instrument of research. Restoration for someone working in a museum and dealing with a collection has the same value as an excavation for an archaeologist. My story today starts from a restoration to become a multidisciplinary project. Our starting point is making the object speak, retrieving as much information as possible about its materiality, invisibility, intangibility, decoding its deeper meaning, recovering its value, making connection with the present world. In 2016, a team from the Vatican Museums set up the second project, following the restoration of the statues of the goddess Sekhmet in the Vatican Museums. There are 11 of them in granodiorite. The restoration was, as always, a time of important reflection and study, and comparison with other Sekhmet statues became urgent, and the group of the Vatican statues was increased to include the Sekhmet statue from the Museo Egizio. Today, the Sekhmet project has become a collaboration between the Vatican Museums, the Museo Egizio, and the team of the Memnon Amenhotep III project. The multidisciplinary working group includes all the people listed in this slide. It is a research and study project on the sculptural production of the hundreds of Sekhmet statues in granodiorite produced during the reign of Amenhotep III for his funerary temple at Komeletan in West Thebes. It is an architectural project unique in the thousands of years of Egyptian history, intriguing in its many aspects, fascinating in its splendid realization, a grandiose litany of stone, to quote the Egyptologist Yoyot. There are hundreds of Sekhmet statues divided into two groups, seated on a throne or standing. At the end of the last archaeological season, a total of 260 statues has been listed in the inventory for the Komeletan site. 288 from the Moot precinct on the east bank of Luxor, 210 scattered around the world, but this figure must rise over time. This gives a total of almost 800 statues, not counting fragments. After a well-known earthquake in around 1200 BC, the area of the funerary temple of Amenhotep III was abandoned, and from that time onwards, the temple was exploited as a stone quarry. The Sekhmet statues were mostly left abandoned on the site. Most of them had already fallen, some remained standing, becoming slowly buried over time. Many of them were later collected by archaeologists and travelers and are now scattered around the globe. The statues remaining on the site have also suffered from fires and from infiltrations, as you can see here, of water from an aquifer in the area. On the basis of the archaeological evidence, the Sekhmet statues were originally all arranged in the area of the peristyle courtyard and the hypostyle hall. The grandiose display of statues of the goddess Sekhmet, that you can see in these reconstructions, daughter of the sun god, formed a powerful defensive chain for the celebration of the said festival of the king. In the shadows of the peristyle courtyard and the hypostyle hall, hundreds of red eyes rendered the goddess even more powerful and terrific. The iridescent polished black stone also reflected flashes of light in the semi-obscurity, and the goddess resulted splendid in her polychrome decorations, the white collar, bracelets, and ankle bands, and the frontal rails. The Diagnostic Conservation Lab of the Vatican Museum has carried out also the scientific analysis to identify the pigments. They were color statues. For the color red, hematite was confirmed. for the blue pigment Egyptian blue, for the yellow pigment a yellow ochre, and the University of Palermo has also analyzed the granodiorite lithotype of all the Vatican statues, which can be divided at the moment into 3 groups. And this is the present state of things, which strongly influences our perception of the statues. A very large number of statues, mostly fragmented, many unfinished statues at distinct phases of production in different state of conservation, with different size, proportion, and lithotype, with inconstant degree of details or inscriptions, difficulty in measuring and moving the statues, conserved in so many different contexts and places, which has led to a confused reading of the set, a distorted perception of the data as a whole, and difficult objective comparison. The project intends to follow the different lines of research which derive from the observation, measurements, and comparison of all the statues. They are measurements and comparison of the dimensional and proportional parameters of the statues with the aim of identifying possible typologies, and also the study of the volume and weight of each individual statue, which will be added to get more information about their transportation. Development of a comparative abacus, I mean the comparison of different iconographic and architectural elements of the statues. So a software development we have called Sekhmet, in order to cross-check and compare all the data from the statues on multiple levels. Database development also capable of dialogue with the Sekhmet software, and then the analysis and recovery of the sculptural project synthesized in 3 main stages: the project conception, the executive project, and did this executive project provide a unique model, or were there already many models, or correspond to different workshops involved coming from different areas of Egypt? There are many possible scenarios opening. And then the sculptural production, so the shape. This third point will also consider a study of the execution technique, from extraction of the stone in the quarry via the rough shaping to the finishing of the shape and surface, and including transportation. Then the study of description on the statues, the study of the damages to the statues, which often appear to have mutilated arms and faces, deliberate damage, ritual damage, or looting, comparison between the Sekhmet statues from Comeletan and those from the Mood Precinct. The project is based on the research and development of innovative investigative methods founded upon the formal and technical archaeological evidences. We are sure of finding answer to the numerous questions posed by this sculptural project itself. I mean its artistic and religious meaning, the design of its setting, the organization of the working sites, the execution technique, and the whole production process as it evolved in space and time. Lacking written documentation, every guiding thought was that of making the statue speak. It means a sort of textual translation of every formal characteristic that was carried out for each statue, which was inserted into a comparative abacus, and at the same time a numerical translation of the proportional and dimensional parameters were made for each statue. But what does numerical translation mean? The numbers are those resulting from the measuring of the statues. Moving back to the first steps, taken with the Vatican and the Turin Sekhmet statues, our first step was to measure them in order to compare them. To take measurements, we used 3D models of the statues, because 3D modeling allows measuring, manipulation, comparison, and observation, otherwise impossible. Above all, in the case of works in a series and also heavy to move and kept in various places, because 3D modeling allows the taking of digital orthophotographs from all the perspective of the statues. The most important advantage is that it can be measured. A high-resolution photograph is then applied to the 3D model, and it represents the skin of the model itself. It means that qualitative information integrates the 3D metric information. The digital orthophotos of a tree model can be compared with the preparatory two-dimensional drawings of the ancient Egyptian sculptor when approaching a block of stone. Both are geometric recording of a monument. Egypt does not sculpt out from within, but rather in from without. Egyptian sculptor proceeds from a set of contour drawings on the block surfaces. So we have identified the cutting planes for each statue and measured its 3D model in all its proportions and dimensions, always keeping the group of standing statues clearly distinguished from those seated. Let's consider the standing statues. The first step was to compare them by size, and by height they were divided into 3 groups. Then we proceeded with comparison of their proportions, inscribing each statue in 18 square grid, according to the canons of the Egyptian art at that time. The silhouette of these Turin statues, as all the others, have been measured in squares in all its proportions, starting from point 0 at the level of the feet. In this table, all the standing Sekhmet statues are recorded according to their proportions in square. They are divided into the same 3 height groups. One important measure to cross-check is the height of the head and the height of the chin, because the chin can be above or below the level of the shoulders or even level with the shoulders. The size of the head and the level of the chin contribute to the production of a more or less willowy figure. Returning to the table of measurements, we then began to play with the numbers. That is to say, we picked out some significant numbers. Immediately, we identified 2 statues with completely opposite values. One, highlighted in yellow, has the narrowest shoulders of all and the largest hips. The other in blue has the widest shoulders and the narrowest hips. The yellow one has the largest head of all, and the chin lies well below the level of the shoulders. This head, big and set back, renders the figure more stocky. The blue one, however, has the smallest head of all. The chin is above the level of the shoulders. This head renders the figure more slender. Going back to the table of measurements, we next extrapolated the average values of proportion, which are shown in green in this table. Then we drew this proportionate silhouette. We looked for this silhouette among all the standing Sekhmet statues, and we got it. In this slide, the 3 different silhouettes were compared: blue willowy figure, green proportionate, and yellow stocky. Later, we drew the silhouette of all the standing Sekhmet statues. As in group 2, statues with the same height can have different silhouettes, and vice versa, the same silhouette can have different heights, as you can see for the yellow silhouette. This is only one example of what it means as translation into numbers of the statues in order to make the numbers speak. Taking a corpus of 30 statues as the batch from the Vatican and Turin, it is still possible to test some relationships between datasets. But at the present state of the research, we are speaking of a corpus of about 260 statues, just to mention those from the site, and of 16 measurements for each status, giving a total of 6,120 measurements. We have therefore sought the collaboration of a mathematician and a machine learning engineer, because we are entering into the field of statistics and artificial intelligence. Statistics is that mathematical body of science that pertains to the collection, analysis, interpretation or explanation, and presentation of data. It is concerned with the use of data in the context of uncertainty and decision-making in the face of uncertainty, how to better define the Sekhmet question at the site. And because our research also falls partly under computer science and more precisely under artificial intelligence, which calls for the application of statistical concepts through human-machine collaboration during the generation of data, the development of algorithms, and the evaluation of results. So the Sekhmet software was born. Its very name underlines the purpose of the software, which is study and research how much more information can possibly be obtained from each one of the hundreds of Sekhmet statues. This software employs the clustering method, a powerful AI technique. Its aim is to construct a natural classification that can be used to cluster the data. The results of this analysis are presented in a dendrogram, that is a diagram representing a tree that shows the hierarchical relationship between data. Let's make an example. We select, for example, only the standing statue outside the Comelatan site, and we compare only for height. In this slide, you see the corresponding dendrogram. The key to interpreting a dendrogram is to focus on the height at which any two groups of statues are joined together. The height difference, it means the distance, means how much different are the clusters, the groups. A big height means big difference between the two groups or clusters. On the baseline, all the statues are identified by the inventory number. If we cut the tree at this height, we see that the group on the left, in this case is a single status, has not so much distance from this second group, but a very big distance from this group of statues. This third group counts 11 statues, which differ only slightly from one another, showing only very small variation in height. The software is working with Excel sheets which gather all the measurements in centimeters and immediately creates the corresponding in cubits and in squares. It's interesting to compare the same dendrogram expressed in three different measurements. You can ask the software to cross the measurements individually or all together, and each time the software will produce a dendrogram. The analysis of each dendrogram is stimulated to explore further. Since the software is based on statistical calculation, it's important to recover the greatest number of statues possible. The greater the number, the smaller the margin of error. It becomes so fundamental, therefore, to be able to enter also the measurements of the great number of fragmented statues in our software. As far as the corpus of statues on which we are working at present is concerned, of the standing statues, only 13 are whole statues, while 62 are fragmented. At first, we would like to recover the original height of these statues in order to compare them with all the whole standing statues. Height is a very important value to better understand the original setting of the statues within the temple. So we enter in the statistic area of the so-called predictive analytics. The first step is to analyze the so-called reference statues, I mean the whole statues, in order to find any correlations between all their measurements. What does a correlation mean? This graph shows, for example, a possible correlation between two measurements, in this case, the height from the forehead to the bust base and from the forehead to the wig base. Each blue point corresponds to a statue. The points are dispersed more or less on a straight line. This means that there is a positive correlation between these two measurements. It means that these one measurements will be depending upon the other one. So it is possible to find out a mathematical relationship between these two measurements of the statues. That graph on the right, on the other end, shows a negative correlation, as the random distribution of the points demonstrates. It is not possible to find a mathematical relationship between these two measurements of the statues. The sum of any positive correlation between all the measurements of the whole statues, thanks to an algorithm of AI, formulates a mathematical predictive model in order to get the prediction, in this case, the height of the fragmented statues. The last step is the predictive model testing. In this slide, the prediction of the height of the fragmented standing statues collected. Here, the height of all the standing statues of our corpus, and at the current state of research, the height that brings together the greatest number of statues is from 1.60 to 1.75. We cannot go into more detail. The sculptural production of the Sekhmet statues holds a treasury of information hidden in their numbers, as we have seen, but it also contains much else thanks to the close observation of the statues themselves. At this stage of the research, we feel able to confirm that the statues taken as a whole represent an enormous construction project never completed, a gigantic work in progress. We have defined it as a fluid production system of sculptures. It means that it did not proceed from the carving and finishing of one statue after another, but as the evidence shows, many statues were being worked at the same time. Let me show it. Just 2 minutes. Greatly inspiring are the granite unfinished statues of Menkaure found in his Valley Temple, now in Boston, which crystallized 3 progressive stages of working. According to this same model, we worked at the reconstruction of the roughly cut quarry block of four-seated Sekhmet statue. The drawing of the first rough carving could have been applied to the 4 sides of the block. It's very likely because of the stone working technique of granodiorite. Granodiorite carving process proceeds through many phases of rough carving by striking the stone with an extremely round-headed scalpel, which was mainly achieved at a perpendicular angle which shattered the surface. To check the evidence, the Comelet site and also the precinct of Moot has brought to light some unfinished statues. They represent the crystallization of a specific moment in space and time, in which the data from the execution technique, the dimensions and proportions of the statues, the recovery of a possible reference model, the phase of execution, and the site of the working cross each other. This one, for example, comes from the Mood precinct. It is very eloquent. It shows the initial squaring off of the shape with the angles well defined in a polyhedral composition. Still from Mood, another one showing the hypothetical successive phase to the previous one. The edges have been rounded and the surface leveled to better define the shape. The difference between the shoulder is clearly visible. One is more squared and the other one more rounded and lower. The whole of the left side seems to have reached a more advanced stage of working. Then we move from one phase to the next, is clearly visible. This one shows the beginning of a detailed anatomical definition. As in the previous statues, the left shoulder is lower and more rounded. The left arm is also more rounded. Was the carving always beginning on the left side and proceeded around the statue? Again, we move from one phase to the next, and it is very clearly visible. This Vatican I shows a later stage of working in which the globular shape of the eyes, nose, and chin have been more clearly defined. The mane has not yet been worked. And here the sequence of phases showing the defining of the details on these unfinished Vatican standing statues. The next step is this Turin statue. The mane and the streaking of the wig have been defined, the whiskers are more detailed, as well the rosetta and braces of the tunic. The next step is these Turin statues. The polishing has reached a more advanced stage. These 2 seated statues from the side are exceedingly interesting too. Same lithotype, dimensions, proportions, and modeling. They differ only in the carving of the detail. The one on the left shows well there has been a first smoothing of the stone, which clearly precedes the carving of the details. Then the iconographic details were carved, as the statue on the right well shows. The white collar, the wig, and the whiskers have been well defined. It lacks only the final polishing and the painting of some details. We could go on, but there is no time, and after this outline, I hope you will be better understand what we mean by a fluid production system of sculpture. In any case, we are in front of a gigantic serial production which can better be defined with the oxymoron serial variety production. The statues can be divided into clusters with the same formal characteristics and execution, produced according to a figurative interpretation of a model over fluid timing, but clearly divided into distinct phases. In any case, the whole production must have been carried out in response to a centralized organization of the construction site. The software Sekhmet will help us to cross-check so many variables and different data. In any case, to imagine credible settings will certainly be a big help in understanding how things were really done. Thank you.